In this series, we're working through the free response questions, or FRQs, from the 2024 AP Precalculus exam. I've taught and tutored this class since it was introduced in 2024, and I wanted to be able to help you to prepare for your own upcoming AP test. There's a link in the description to download the PDF of these problems. Also check the timestamps if you'd like to skip to a certain part of the video. This video will cover problem number 1, which requires a graphing calculator. And on the test, you'll have 30 minutes to complete this problem as well as problem number 2. Both of them are graphing calculator problems. This problem is all about functions. Some key concepts that come up all in this one problem are function notation, composition of functions, inverses, domain and range, end behavior and limit notation, as well as just generally your ability to use a calculator. Alright, let's get into it. So number 1 says, the figure shows the graph of the function f on its domain of negative 3.5 is less than or equal to x is less than or equal to 3.5. The points negative 3, 1, 0, 1, and 3, 1 are on the graph of f. The function g is given by g of x equals 2.916 times 0.7 to the x power. And they do give us this figure here to look at, and everything that they just told us, you can already see that in the picture. But now we know for sure that the domain is negative 3.5 to positive 3.5, so we don't have to guess about that. And these are closed circles, so we can see that this is the entirety of the graph of f. Like, this function doesn't exist anywhere outside of what we can see here. So that's good to know. They also tell us that negative 3, 1, 0, 1, and 3, 1 are all on the graph. And you can already see that. But for example, this point 1, 3 looks like it's on the graph, but honestly I can't be sure because they didn't state that in the problem. I'm kind of hoping that that doesn't come up in any calculations. Same thing for negative 1, negative 1. So we have two functions that we're working with. The function f shows up as a graph, and the function g they tell us as an equation. Alright, so let's see what we're supposed to do with all this information now. Part A says the function h is defined by h of x equals g of f of x. And g of f of x is just written in two different notations here, but they mean the same thing. Remember, from compositions of functions, this means that we're taking the entire function f and plugging it into g. So imagine taking all of the points off of this graph, all of these in-between points as well, and feeding them through this function g and seeing what you get for your output. That's the function h. Then it says find the value of h of 3 as a decimal approximation or indicate that it is not defined. So let's just cover this real quick. They say indicate that it is not defined, and that could just happen like if you get some kind of error message on your graphing calculator, or if the value is outside of the domain or outside of what we see here. But h of 3 means we're plugging 3 in, that's the input for x, and we want to see what we get out. And h is the composition of these two functions. So we need to plug 3 into the function f first. And our function f shows up as a graph. So if we look at where x is 3 and then follow that up to the graph, we can see that the output is 1. And again, they verified that for us in what they stated in the beginning of the problem. 3, 1 is on the graph of f, so we can be sure of that. So what that means is f of 3 equals 1. So instead of writing f of 3 here, I can put 1. So this says g of 1. This is the next step. After evaluating f, now we evaluate its output into g. So g of 1. Well, g was an equation. It's 2.916 times 0.7 to the x power, but I'm going to plug 1 in there. And we're definitely going to need a calculator for this just because of all the decimals happening. But 0.0 to the first power, we don't need a calculator for that. That's just 0.7. So all you need to type in is 2.916 times 0.7. And you should get 2.0412. And they asked for a decimal approximation, but they didn't specify where to approximate to, and honestly this is the entire answer. The decimal doesn't continue past that, so I would just leave it that way. So moving on to the second part for part A, it says find all values of x for which f of x equals 1, or indicate that there are no such values. So we're back to function notation, and it's important to note that this 1 is the output, or the y value. So if we look back at our graph and we look for all of the values where the output is 1, here's where all the y values are 1, it's just a horizontal line here. That crosses f at negative 3, 0, and 1. Remember, those are the 3 points they told us about in the beginning of the problem. So I'll say x equals negative 3, x equals 0, and x equals 3. So the difference between the first and second part of part A here is that in part 1, they gave us the input was 3, we had to plug that in and then get an output was 1, and then we plugged that into the next function. So they were giving us all these inputs, and we gave them the output. In the second part, they gave us the output, and we had to tell them the inputs. Moving on to part B, it says find all values of x, kind of like the last problem, find all values of x, this time as decimal approximations for which g of x equals 2, or indicate that there are no such values. So the reason they said the decimal approximations thing is now we're dealing with g of x, which is this weird function with a lot of decimals going on, so our answer might be a decimal. So they want to know where g of x equals 2. And again, they're telling us the output is 2, and we have to solve for x, or the input. And I want to show you two different ways that you could handle this. First, we'll solve this algebraically, kind of by hand, and the second, we'll just use our graphing calculator to do all the work for us. So the function g of x is 2.916 times 0.7 to the x power, and they want that to equal 2. So for solving for x, we'll start by dividing by 2.916, and we'll do that on both sides. So you get 0.7 to the x power equals 0.68587, and I'm rounding out to the 5th decimal place, which is kind of excessive, but I don't want my answer to be too far off at the end, so I don't want to round too much here in the middle of the problem. But now we have to get rid of this base of 0.7, which is going to require logarithms, not dividing, right? Not dividing by 0.7, because this doesn't say 0.7 times x, so division won't undo it. We need to use a log. So you may have learned how to either just rewrite this exponential equation in log form, or maybe you just take the log of both sides. I like to do it that way, so I'm going to show you, I'm going to take the log base 0.7 of 0.7 to the x power, and then I'll take the log of the right side. Again, 0.7 is the base, and the reason we take the log here, again, is to get rid of the base. So log base 0.7 of 0.7, that all cancels, and we're left with just x equals, and then this side is just calculator work. Now some calculators can handle different bases. They'll give you a little spot to type in 0.7. Other calculators can only do the common log, or log base 10. And if that's the case, you probably learned the change of base formula so that you can use your own calculator to do this. And just as a reminder, the way we write that is the log of this number in the parentheses. So log of 0.68587 divided by the log of the original base, which in this case was 0.7. And so what we've done is we switched the base to be 10, just the common log, so any calculator can handle this. And I'm getting 1.0572 if you round. So this method requires you to have a better understanding of how to solve equations by hand. And as you saw, you needed to be pretty confident with logarithms. The second way is just to plug this into your graphing calculator, which requires a little bit more graphing calculator ability, but less manual work. So the way we'll do this is go to your y equals screen on your calculator and type g of x into y1. Then in y2, just type in 2, because we want to know where g of x equals 2. And then if you graph this with a standard viewing window, so -10 to +10 on the x and the y axis, you should get something like this. And you can see that the two graphs intersect. Now, I'm not going to tell you the steps to do next because every graphing calculator is a little bit different, but your graphing calculator should have the feature to find the intersection point between two graphs, or two curves. So do that, and you should get the same answer we got before, 1.0572 if you round. And while we have the graph to look at here, the second part of B says, determine the end behavior of g as x increases without bound. Express your answer using the mathematical notation of a limit. And as you can see on the graph, if x increases without bound, in other words, we're going to the right? If x is increasing, it's getting bigger, so bigger positive numbers. If we go farther to the right, or if x approaches infinity, which is what we're going to write, the graph is decreasing, but it seems like it levels off. It's not going to go down into the negatives. It seems to have an asymptote at 0. So we could write the limit of g of x as x approaches infinity equals 0. And if you know enough about exponential functions, you might even know that without looking at the graph. Since 0.7 is less than 1, this is exponential decay, or the graph is decreasing to the right. So if you start with 2.916 and repeatedly multiply by 0.7, you'll eventually get closer and closer to 0. Alright, so letter C says determine if f has an inverse function. And the wording here can be kind of tricky, because honestly, everything has an inverse, and this function f that they have graphed for us has an inverse. Anything does. An inverse just means you switch all the x and the y values. So for instance, this point here, let's see, -3, 1 would become the point 1, -3. It would end up down here. This point here, 0, 1, would become 1, 0. And you could do that for all of the points on this graph. You've also learned that inverses reflect over the line y equals x, so you might even be able to do that visually just by reflecting all of these points. But what they're really asking about is if the inverse is a function. And it's actually pretty easy to determine that. You just have to use the horizontal line test. So if you draw a horizontal line through the function, anywhere through the function, it should only ever hit it once. It's kind of like the vertical line test, but they do tell you different things. If you check the vertical line test, that tells you if what you're looking at is a function. And I already know that this is a function. They told us it's the function f. And this vertical line would pass through only once anywhere on this function. But if I draw a horizontal line, you can see that it hits 3 different places on this function. So it fails the horizontal line test. That tells me that the inverse of this is not a function. So the horizontal line test was an easy way to check if the inverse was a function or not. But the second part of this says give a reason for your answer based on the definition of a function and the graph of y equals f of x. So if you're not sure how to answer it based on the definition of the function, the least you can do is mention something about the horizontal line test and how f fails that. But let's try to write something about the definition of a function. And the idea here with functions is that if you give me an input, there should only be one output. But remember, with inverses, x and y switch, or inputs and outputs switch. So it's kind of like saying if you give me an output, I should only be able to give you one input of the original function. So if we look back at this function f, that's the original. Again, I don't have the inverse here to look at, but if you look at the original function and give me one output, I should only be able to give you one input. But that's not the case. If you tell me the output is 1, I can find you 3 different inputs where that happens. In other words, the inverse of f is not 1 to 1. So I hope that helped you to make sense of the first problem. In the next video, we'll take a look at the second graphing calculator question.